Hey kids, we're going to talk about polar graphs today, but we're going to focus just on lines. So we know now about circles and roses and whatever, but limacon, cardioids, all that kind of stuff. We want to talk about what if we did just want to deal with lines in polar form. So going all the way back to the end of first semester, we talked about the normal form of a line. Do you remember? I'm not surprised. That's okay. It was at the end of a long semester. So here is the formula that we gave you about the normal form of a line. And remember that we had this cosine of phi and sine of phi, where phi was the angle that the normal from standard position, that the normal, and we called this the normal, made to our linear function, right? That was the normal form of a line. So look at what I'm going to do. I'm going to replace x and y in this exact same equation with r cosine theta and r sine theta. And then I'm going to factor out the r. And then I'm going to say to myself, I've seen this formula before. Cosine, cosine plus sine, sine. Notice I moved the p over to the other side. That is the cosine of a difference. The cosine of a difference formula right here. So I have the r outside, and then the cosine of a difference, and the p on the other side. So that is the two forms of polar. And the only difference between this equation and this is I got r by itself in this equation, right? Where I just divided everybody by cosine of theta minus phi. Okay? P again is the length of the normal, and the normal is from the pole or the origin. The normal, remember normal is perpendicular. And phi is the angle from the standard position up to the normal, okay, that the normal makes with the positive x-axis. So look at those two lines that I've made. This is a normal again. This is just some standard, right? Any point on the plane. Now, if I'm in polars, on the line, if I'm in polars, remember this point is represented by r comma theta, right? And remember this angle again is phi from the positive x-axis up to the normal. But I want you to look at this right here. Isn't that a right triangle right in there? And then I want you to look at this angle. If I'm graphing in polars, right? Graphing in polars, here's the radius out to this point. So this is r. Out to the p, and then, out to the big, that's a capital P, not little p. And then remember this is theta, right? Well, look at my yellow triangle. With my yellow triangle, remember I have a right angle here. This distance we said was p. It is the distance from the origin to the green line. Notice though, with my right angle right here, can't I say that the cosine, right? The cosine of an angle is the opposite. So here's, the adjacent, and the adjacent is p over the hypotenuse. What do we call the hypotenuse? R, right? But what is the angle inside my yellow triangle? What is this angle? This angle right here. It's not theta and it's not phi. Remember, the big blue angle is theta and this angle is phi. Oh, my Lanta. Isn't the cosine in my yellow triangle of the angle that is theta minus phi equal to the adjacent over the opposite? Oh, snap. What does that say? Multiply both sides by r. What do you get? Well, there. Math is pretty cool, isn't it? Right? Pretty cool. OMG. Right, so I just showed you algebraically why the polar form of a line looks like this, right? With, if you remember, the cosine of right, of a difference, but geographically, geometrically, I showed you the same thing. Pretty cool, right? Math is cool. So this is a problem that we had on a warm-up last week. And we used the cosine of a difference formula to figure out how to go from polar back to rectangular. Today, if you recognize the polar form of a line right here, you don't need to remember the cosine of a difference formula. If you recognize that this is phi and this is p, then you're going to know how to go take this into rectangular form without having to remember this formula, right? And after all, right, if you, this again is p. For our example, this length is going to be 2, and phi is pi over 3. And that nails down that green line. If you want the rectangular coordinates, plug in 0 for y, and you get x is equal to 4 in rectangular, and plug in 0 for x, and y is 4 over root 3. Right? Pretty cool. So let's do some examples where here's rectangular form, 3x minus 1. Here's what the graph looks like, right? Y-intercept of -1, slope of 3. I want you to convert this into polar form. So step 1, you got to go to normal form. So actually, pre-step 1 is getting into standard form, right? I don't care which side you put the 0 on. I just put it over here to keep my x positive. So I moved the y over and I kept the -1 there. Then from previous, right, what we did is we took the 3 and the -1, did Pythagoras with them, got root 10. Then we divided each term by root 10, including the 0. So of course I still have 0. Then we had to recognize this is, right, in front of the x, in front of the y, and what p is. So p, remember, is a distance, so it's always positive. So that's 1 over root 10, which is pretty small. And then you needed to remember from, right, that this is cosine of phi x minus sine of phi y. So cosine of phi must be 3 over 10. Sine of phi must be negative, and that's important because if your cosine is positive and your sine is negative, what quadrant are you in? Quadrant 4. That's not a special angle, and so I just used my calculator, and notice they told me they wanted me to be in degrees, and they wanted me to round to a whole. So that's what I did. So what that means here is that to go perpendicular from the origin to perpendicular to that line, That distance, the length of that purple line is 1 over root 10. And the angle with the positive x-axis that makes is either 342 degrees, or if you want to think about it, is with the negative is negative 18 degrees. I don't really care which one you write it. I chose the positive. Okay, cool. Next, go backwards, right? So before, now, if you don't remember the linear form, right, of polar form of a line, okay, well, then you're just going to have to realize, oh, that's a sum. I got to remember my cosine of my sum formula, right? And then do math and convert. But if you recognize this, right, you're like, I've seen this before. You recognize what? 5 is your P. And what's phi? Negative pi over 6, right? Phi is negative pi over 6. So then write your equation in normal form. How do I do that? For normal form, I need the cosine of phi. Well, that's the cosine of negative pi over 6 is negative pi over 6 is in quadrant 4. So cosine is positive, sine is negative. So cosine of phi x minus sine of phi y minus p is equal to 0. I'm in normal form. Simplify that a bit, get rid of my fractions, and there you go. Here's what the graph of that looks like. Now in rectangular form, again, plug in 0 for x, and notice that y is negative 10. Plug in 0 for y, and you figure out that this is, 10 over root 3? But that line is exactly the same thing as this line, just in a different form. Rectangular or standard versus polar. So what if I asked you to graph from polar form? What would you do? You would recognize that this is P, so you're going to go approximately a distance of 5. Right? Out a distance rate, go a distance of 5 from the origin to quadrant 4. And rotate negative pi over 6. So of course, if you actually want to do the positive, it would be 11 pi over 6, right? So graphing, sometimes you might just want to graph from polar form. So look at this one. Can you recognize my line? I recognize you, right? This really is r times cosine of theta minus 3 pi over 4 is equal to 4. Therefore, 4 is my P, and 3 pi over 4 is my phi. So I want to go out 3 pi over 4 is in quadrant 2. Here it is. Radiate out 1, 2, 3, 4. P is equal to 4. And the angle again with the positive. And you want to draw your line through there. Notice if I do that, it looks like, now this is right, the positive y-axis. It looks like the y-intercept is 1, 2, 3, 4, 5-ish, and the x-intercept is 1, 2, 3, 4, negative 5-ish, right? Probably not exactly, but convert this, right? I encourage you to go ahead and practice conversion and convert that into rectangular form and see if you get those x and y intercepts. So your handout tonight is going to ask you to, or after this video is going to ask you to do those three things, right? The things that you're going to be given rectangular, go to polar, given polar, go to rectangular, and then 3, graph from polar, form of a line. So again, for number 3, if you want to remember, right, if you want to, right, use your other formula, your sum or difference of the angle there of cosine, go ahead. But this is going to be a quicker way. So really, this whole lesson was kind of just a shortcut in a very specific type of polar graph that you can quickly sketch it without a calculator, right? Using just the distance and p and phi, how you rotate from the positive x-axis. All right? We will practice some more of this in our next live session.